The next concept I would like us to talk about is the gradient or slope. Now, what is the definition of the gradient? Well, the official definition of the gradient, for which in mathematics you use the lowercase m, is the change in y divided by the change in x. And change is nothing else but the later amount minus the starting amount. And because it's the change for both of them, so I just need to find that difference for the numerator and the denominator. But what are these y's in here and x's? Well, these are just the coordinates of points on the line. So the gradient is a very important concept because the gradient tells us how fast, how steep a line graph changes. So sometimes you might have heard about this as the rise over run. Sometimes they also refer to it. Or rise over run. Okay, so how can we calculate it? Well, we're gonna need 2 points on the linear graph, but as soon as we know those 2 points, we can use their coordinates and then just calculate the gradient from there. So if you were given 2 points, let's say 2, 9 and -1, -3, how can you calculate the gradient? Well, first of all, you need to choose which point is 1 and which point is 2. Well, I'm just going to choose this point to be x1, y1, and this point to be x2, y2. So this is my first, this is my second point. X coordinate comes first, y coordinate comes second. And from here on, we just need to pick up these numerical values and substitute it back into the formula. So gradient equals y2 minus y1 over x2 minus x1. That is equal to y2 is -3. So -3 take away y1 is 9 over x2 is -1, take away x1 is 2. So -3 take away 9 gives you -12, and -1 take away 2 gives you -3. Negative divided by negative gives positive, and 12 divided by 3 gives you 4. So the gradient of this graph, or the slope of this graph, is 4. What it means for me? Well, it means for me that if I change 1 in the x direction, I'm gonna have to go up 4 in the y direction. And because it's positive, I'm going in the positive direction with both of them. Now, what if I decided to choose the points order slightly differently? What if I said that I want this to be x1, y1, and this point to be x2, y2? Would that make any difference to the gradient? Well, let's check. M is still the same definition. So y2 now is 9, and I need to take away from it y1, which is -3. x2 is now 2, and I need to take away from it x1, which is -1. So what happens now? 9 take away negative gives me adding, so 9 plus 3, same here. So that is 12 over 3, which gives me 4. The gradient gives you exactly the same numerical value. Doesn't matter which point you're choosing first and which point you're choosing second. So it's up to you. Now, it's all nice and lovely, but what can we use these gradients for? Well, we can use the gradients, for example, to decide if a graph is upwards or downward sloping. What do I mean by that? So if here is the coordinate system, this is x, this is y. This is a graph which we call an upward going graph, and this is a graph which we call a downward going graph. What happens in these two particular cases? Well, the gradient here for this one, m will be always positive, but for this one, the gradient always going to be negative. Another important thing is how can we compare the changes in x and y's in both of these cases? Well, as I'm going up in the x direction, to keep on the graph, my y is also going up. So with a positive slope, as x goes up, y goes up. Now, if I start to go down in the x direction, my y is also coming down. So if x comes down, y comes down. What we can see in here, if I have got a positive slope, the two coordinates are changing in the same direction. So there is a direct proportional link between the two coordinates, or the two quantities if we can talk about price and quantity. But what happens with the downward slope graph? As I'm going up in the x direction, my y starts to decrease. So x going up, but y going down. Now what happens if I decide to go down in the x direction in the negative way? Well, the y direction starts to go up. So as x comes down, y goes up. And this is going to indicate an indirect relationship between the two quantities that are drawn to the x and the y.